On the 24th of April 1990, Space Shuttle Discovery launched the Hubble telescope into orbit. This was an exciting time for space exploration, as Hubble promised to produce mind-boggling images, showing us an early view of our universe as it was forming. But as soon as Hubble came online, scientists noticed a serious problem with its mirror. Although this was the most precisely cut mirror ever made, a slight defect of just 2,000 nanometers meant that Hubble failed to produce sharp images. After 3 years, scientists managed to produce a fix for the mirror, and Hubble began scanning the universe for its secrets. Since then, Hubble has operated for nearly 30 years, capturing the most stunning images of distant stars and galaxies. But, like everything, Hubble has its limits, and the world's most famous telescope will eventually come to an end in the not-too-distant future. But how long does it have left, and why has it reached a limit in terms of what it can observe? Throughout its lifetime, Hubble has taken millions of amazing pictures. It's able to observe other parts of the electromagnetic spectrum that an ordinary telescope couldn't see. Since it's outside of Earth's atmosphere, it has an unobstructed view of the universe, which allows it to capture objects that are dimmer and much more distant than a ground-based telescope ever could. Despite this, Hubble's best images have come and gone, and the limitations of physics will likely stop it from seeing anything dimmer or further than it already has. In order to observe the furthest and dimmest objects in the universe, you need an extremely high-resolution telescope and the ability to capture as much light as possible. The resolution of a telescope is limited to the number of wavelengths it can fit across its mirror. The angular resolution of a telescope measures its ability to identify two separate objects that have a short angular distance when observed by a telescope. This is given by 1.22 multiplied by the wavelength of the light over the diameter of the mirror. When observing visible light of about 500 nanometers, Hubble has an angular resolution of about 0.05 arcseconds. This beats the human eye's resolution by a factor of 1,000. For even shorter wavelengths like ultraviolet, the resolution gets even better, and Hubble can achieve an angular resolution as low as 0.01 arcseconds. Hubble is also limited by the types of wavelengths it can observe. Stars emit a wide range of light, and although Hubble can observe a wide range of wavelengths, it can't observe anything greater than near-infrared. This limits its ability to look back in time to distant objects. As the universe expands, the fabric of space expands with it. When light travels through the universe, its wavelength is stretched with the expansion of space. This means that by the time the light arrives at Hubble, the wavelength of the light is longer than when it left the object. This is known as redshifting. As the distance to an object increases, the longer its light will spend traveling through space, and the more redshifted it will get. If the light is redshifted too much, it could be stretched to a wavelength outside of Hubble's viewing range. One of the main goals of the Hubble telescope was to find the most distant galaxy in the known universe. It achieved this in 2016, when it discovered galaxy GN-Z11. This galaxy is located 32 billion light-years away, and the light we see from it shows the galaxy as it was 13.4 billion years ago. This galaxy is at the very limit of how far into the past Hubble can see, and it was discovered due to some incredible circumstances. The galaxy just so happens to be in an area of the universe where there is very little neutral gas between it and Hubble. This gave the telescope a clear view to observe the galaxy. The light coming from the galaxy passed by another nearby galaxy, which caused it to be gravitationally lensed. This happens when the light from an object is bent by the gravitational pull of another object. Light that would otherwise miss the observer is bent in a way which directs it toward the observer. This caused the light from galaxy GN-Z11 to be magnified, just enough for Hubble to observe it. So far, Hubble has been capturing these stunning images for 29 years. Due to its design, Hubble was capable of being serviced in orbit. Over the years, the Space Shuttle crew visited Hubble on 5 separate missions to fix and replace faulty components. However, since the shuttle program ended in 2011, we no longer have the ability to maintain Hubble, which is starting to take its toll on the telescope. Hubble has 6 gyros on board, which it uses to maneuver and point its telescope precisely toward its target. In the last 5 years, 3 of these gyros have failed. Even if Hubble continues to function over the next decade, its orbit is constantly decaying, and in the 2030s, Hubble will crash into the atmosphere and burn up before reaching the ground. By the time this happens, the next generation of space telescopes will be in orbit, producing even more stunning images of our universe. But Hubble's groundbreaking images will never be forgotten. So, although Hubble will be decades old before it retires, its existence will be a mere flash compared to the age of the objects it's managed to capture. Nevertheless, the incredible engineering and science behind this telescope helped us take an enormous step forward in our understanding of the universe.